मैं इस देश हित में सॉफ्टवेयर बेस्ड जो अध्ययन हो रहा है उसे मेरे लाइव क्लासरूम से इस देश के छात्रों के हित में मैं YouTube चैनल के मार्फत जोड़ना चाहता हूँ। इसमें आप लोगों का मार्गदर्शन चाहिए ताकि और हम बेहतर क्या कर सकें।
EMF equation. In this animation, we are going to see the EMF equation. An ideal transformer is one that has no losses. The primary coil is purely inductive and the secondary coil is opened. The AC voltage is applied to the primary side. When the voltage is applied to the primary, it draws no load current. The flux increases from its zero value to maximum value, that is 1.5 meter in 1/4 of the cycle, that is 1/4 frequency second. Primary induced EMF E1 is equal to 4.44 Fn1 1.5 meter volts. Secondary induced EMF E2 is equal to 4.44 Fn2 1.5 meter volts. Voltage transformation ratio. We are going to see the transformation ratio of the transformer. Let us consider autotransformer, flux lines, load. E2 by E1 is equal to N2 by N1 is equal to K constant. This constant K is known as voltage transformation ratio. For step-up transformer, the induced EMF in the secondary side is greater than the induced EMF in the primary side, that is E2 greater than E1. The voltage in the secondary side is greater than the voltage in the primary side, that is V2 greater than V1. Then the transformation ratio is K greater than 1. For step-down transformer, the induced EMF in the secondary side is lesser than the induced EMF in the primary side, that is E2 lesser than E1. The voltage in the secondary side is lesser than the voltage in the primary side, that is V2 lesser than V1. Then the transformation ratio is K lesser than 1. Problem 1. We are going to solve the problem based on transformation ratio. Given data, primary induced EMF, that is E1, is equal to 4400 volts. Secondary induced EMF, that is E2, is equal to 220 volt. To find transformation ratio, that is K, is equal to formula used, transformer ratio, that is K, is equal to E2 by E1. Solution: transformation ratio K is equal to E2 by E1. K is equal to 220 by 4400. K is equal to 1 by 20. K is equal to 0.05. Result: transformer ratio, that is K is equal to 0.05. Problem 2. We are going to solve the problem based on transformation ratio. Frequency F is equal to 50 Hz. Number of primary turns, that is N1, is equal to 400. Number of secondary turns, that is N2, is equal to 1000. To find transformation ratio, K is equal to formula used, transformer ratio, that is K is equal to N2 by N1. Solution: K is equal to N2 by N1. K is equal to 1000 by 400. K is equal to 2.5. Result: transformation ratio, that is K is equal to 2.5. Problem 3. We are going to solve the problem based on transformation ratio. Frequency, that is F, is equal to 50 Hz. Primary voltages, that is E1, is equal to 520 volts. Primary turn, that is N1, is equal to 400 turns. Secondary turn, that is N2, is equal to 1000 turns. To find voltage induced in secondary, that is E2, is equal to peak value of flux density in the core, that is Pm, is equal to voltage induced in secondary, that is E2, is equal to Ke1. Peak voltage of flux density, that is Pm, is equal to E1 by 4.44 Fn1a. Solution: E2 by E1 is equal to K. Therefore, E2 is equal to Ke1. E2 is equal to 2.5 into 520. E2 is equal to 1300 volt. E1 is equal to 4.44 Fn1 Pma. Result: voltage induced in secondary, that is E2, is equal to 1300 volts. Peak value of flux density, that is Pm, is equal to 0.976 Wp per meter square. Problem 4. We are going to see the problem based on transformation ratio. Frequency is 50 Hz. Input voltage V1 is 3000 volts. Core flux density is 1 Weber per square meter. Core cross section is 20 centimeters into 20 centimeters. Find the number of turns in the primary side, that is N1, number of turns in the secondary side, that is N2. Exercise 1. We are going to see the problem based on transformation ratio. Number of turns in primary side N1 is 350. Number of turns in the secondary side N2 is 38. Also calculate the primary current, and when secondary current is 200 amps at 0.8 power factor lagging, if the no load current is 5 amps at 0.2 power factor lagging. Exercise 2. We are going to see the problem based on transformation ratio. Input voltage P1 is 1600 volts. Calculate current flow in the secondary side I2.